All right, let's get right into this. Tucked away in ancient Sanskrit texts, there are stories that have been passed down for thousands of years. And most of the time, we just file them away under mythology. But there's this one story that's just a little bit different.
What makes it so different are the details. They're so specific that they feel less like a fairy tale and more like an observation. And that one single fascinating idea is exactly what we're going to explore. So, to really get why these details are so striking, we have to jump into the story itself. Let's set the scene and meet the main characters in this cosmic drama. Okay, so at the very center of all of this, we have a celestial family. You've got Surya, who is literally the sun god. His wife is Sanjana, and she's the daughter of the divine architect of the whole universe. And they have two kids, twins named Yama and Yami. And at the beginning, everything is great. It's a world of perfect harmony. Now, here's a really key detail. The name Sanjana isn't just a name. In Sanskrit, it actually means consciousness or awareness. Just hang on to that little fact because it becomes incredibly important as this whole thing unfolds. But as you might have guessed, this perfect harmony doesn't last. The story is about to take a really sharp turn, throwing everyone into a sudden world-changing crisis. The text describes this change with this sort of chilling simplicity. It just says that suddenly, something was fundamentally, deeply wrong with the sun. It became too bright. And we're not just talking about a sunny day. This was an intensity that was just wrong, something completely overwhelming. And along with that blinding brilliance came this incredible heat. It was just too hot. A kind of heat that nothing could tolerate, not even the beings closest to the sun itself. So this is the crucial point, right? This wasn't a normal heat wave or a really strong midday sun. The texts are super clear about this. It was an unprecedented event, something that had literally never happened before. And that's what made the light and the heat completely unbearable, a true cosmic anomaly. So faced with this impossible situation, Sanjana, remember, she's consciousness, she comes up with a really desperate plan. And this is where we get to the shadow's deception. What she does is create a perfect copy of herself, and she names her Chaya. And the symbolism here is just wow, because Chaya literally means shadow or shade. She literally creates shade to stand in for the light. So now you have these two figures, right? You've got Sanjana, the real consciousness, who just cannot handle the sun's new intensity. And then you have Chaya, the shadow, a perfect copy made to take her place. It was a flawless deception. So where does Sanjana go? Well, the text is really specific again. It says she went to the cooler region, not just away, but to a place that is literally defined by its lower temperature. It tells us that geography and climate are part of the story. And for a while, the plan actually works. Surya, the sun god, is completely fooled. Chaya, the shadow, plays the part so perfectly that she even has a son with him, Shani, who we now associate with the planet Saturn. But, of course, deceptions like this can't last forever. Eventually, the truth has to come out, and when it does, it leads to this desperate search and a really unexpected reunion. The way they get back together happens in these dramatic steps. First, Surya finds out about the deception. Chaya tells him everything, that Sanjana fled south to that cooler region. So he goes looking for her, and he finds her, but she's transformed herself into a mare, a female horse. So what does he do? In this amazing moment, he transforms himself into a stallion to join her. And from this reunion, when they were both in horse form, twin sons are born. And these are the Ashwini Kumaras. Now, they're not just any gods. They are the divine physicians, the great healers of the celestial world. And here's another one of those fascinating little details with a real astronomical link. The Ashwini Kumaras are associated with the twin stars Beta and Gamma Arietis. They appear in the sky right before sunrise. They're known for speed and movement, but most importantly, their whole purpose is healing and restoration. The solution to the crisis is literally born from the escape. So the birth of these divine healers, it signals the beginning of the end of the crisis. It brings us to the final act of the story, restoration and healing. The story's ending is actually really simple, but so powerful. Sanjana returns to Surya. The very fact that she can come back, that she can once again be in his presence, that's the sign. It means the crisis was over. The sun was bearable again.
So if we just step back for a second and look at the whole arc, it's pretty clear. It all starts with a crisis. The sun goes haywire. That leads to the flight of consciousness to a cooler place. That's followed by the deception, where a shadow takes her place. Then comes the reunion, where the sun finds her again. And finally, restoration, where everything goes back to normal.
And that really brings us to the core takeaway here. The story doesn't end in tragedy. It ends in complete restoration. It means that whatever this extraordinary, terrifying event was, it was temporary. So we're left with this, an ancient story, thousands of years old, filled with incredibly specific details about a temporary solar event. And that leads to a pretty fascinating question, one that kind of bridges that gap between ancient myth and modern science. What could possibly make our sun, our real sun, suddenly become too bright? And what could that mean for us?
Let's talk about a man who looked deep into an ancient myth, and somehow he pulled out a number, a really precise date that was hidden in plain sight for thousands of years. This is the story of the man who did the math.
So, what if an old story, one of those tales passed down forever, wasn't just a story? What if it actually had a hidden date inside it, like a secret timestamp for an event that happened so long ago we've completely forgotten about it? And that date? 7,200 BCE. Yeah, that's more than 9,000 years ago. So how in the world could anybody figure that out just from an old text? Well, it all starts with a guy who just thought about things a little differently. Picture this. It's 1903, and our main character, our scholarly detective, is an Indian scholar by the name of Bal Gangadhar Tilak. And he's about to kickstart a revolution, not in politics, but in our understanding of ancient history. Now, Tilak wasn't just any scholar. This guy was a total powerhouse. He was a brilliant mathematician, a world-class expert in ancient Sanskrit, and a revolutionary fighting for Indian independence. That's a pretty rare mix of skills, and as it turns out, it was the perfect combination to crack this puzzle. And this quote right here, it just perfectly sums up his whole approach. You see, while everyone else was reading the ancient Vedas for spiritual wisdom, Tilak was reading them like a scientist. He was hunting for the astronomy. He wanted the data, not just the dogma. And this led him to a huge realization. He figured out that the Vedas weren't just myths. They were absolutely packed with precise, technical, astronomical observations. The people who wrote these texts were incredible skywatchers, and they actually coded their observations right into their most sacred stories. Okay, but that begs a pretty big question, right? How can you possibly put a date on a story using only the stars? It sounds totally impossible. But Tilak knew about a very special kind of clock in the sky. And that clock is called the precession of the equinoxes. Basically, it's this incredibly slow 26,000-year wobble of the Earth's axis. Like when you spin a top and right before it falls, it starts to do that slow circular wobble? That's precession. So this wobble acts like a giant celestial clock. As the Earth's axis drifts, our view of the stars on any specific day of the year, let's say the first day of spring, it slowly changes. Over thousands of years, the constellations that mark our seasons seem to slide backward across the sky at a rate that is perfectly predictable. 1 degree every 72 years. It's a clock that ticks really slow, but it's incredibly reliable. Honestly, the best way to think about it is like carbon dating, but for astronomy. If an ancient text gives you a clear description of which constellation was rising at dawn on a specific day, you can use precession to wind the clock backward and figure out exactly when that observation must have happened. All right, so Tilak has his tool, now he just needs to find the clues, and this is where we get into decoding the actual star story. Deep inside these ancient stories, Tilak found 3 very specific clues. First, these twin gods, the Ashwini Kumaras, were identified with 2 specific stars in the constellation Aries. Second, the story says they are awakened by dawn, which is a very precise term for what's called a heliacal rising. That's the first moment a star is visible in the sky right before sunrise. And third, the whole event is tied to the cooler region, which is a pretty clear reference to the winter solstice. So you put those clues together, and what do you get? You get a single, totally unique astronomical fingerprint. The rising of those 2 specific stars in Aries, just before the sun, on the exact day of the winter solstice. This isn't some random thing.
This specific alignment only happens once in the entire 26,000-year cycle.
So Tilak had the celestial setup. All that was left was to do the math. And the date that he came up with, well, it would become a truly radical theory, one that was basically forgotten for almost 100 years.
He crunched all the numbers, working backwards in time, accounting for that slow wobble of the Earth, and he landed on a date, 7200 BCE, give or take about 80 years. We're talking more than 9,000 years in the past.
Now, to really get just how radical this was, you have to remember that in 1903, the accepted wisdom was that these texts were written around 1500 BCE. Tilak was claiming they held a memory from over 5,000 years before that. It was an absolutely mind-blowing claim. And the reaction from other scholars was, well, exactly what you'd expect. The general vibe was, you're reading way too much into this. The Vedas just can't be that old. His idea was just too far out there for them. And so Tilak's calculation was noted, it was filed away, and for the most part, it was just forgotten by mainstream academics. It was seen as, an interesting idea, maybe a little too imaginative, but definitely not something to be taken seriously. But it just leaves this massive question hanging in the air. A question that kind of haunted the pages of his book for decades. What if he was right? Because think about it, if he was right, the implications are just staggering. It would mean that ancient people 9,000 years ago were making incredibly sophisticated astronomical observations and that they had a way to preserve that data perfectly for hundreds of generations. So this was the problem Tilak was facing. He had the astronomy, he had the math, and he had the ancient texts all pointing to this one conclusion. It was a really powerful argument, but he was missing the one thing that could convince everybody else: independent physical proof. And that was the ultimate challenge, wasn't it? What kind of physical event from 9,000 years ago could possibly prove his date was right? He had the timestamp, but he couldn't prove what the timestamp was for. And back in 1903, finding that kind of hard physical evidence, it just seemed completely and utterly impossible. His theory was just stuck, a fascinating idea that was basically unprovable.
So Tilak's calculation just sat there for over a century. A mathematical ghost story. A radical idea with no way to test it. It really seemed like it was going to be a footnote in history forever. But then came 2022.
So here's the setup. We've got two completely separate timelines. On one hand, you have a scholar back in 1903 using ancient texts and astronomy, and then 119 years later, you have scientists in 2022 using things like ice cores and isotope analysis. And the key thing here? They had absolutely no clue about each other. That's what makes this so incredible.
Okay, let's start with that scholar from 1903. Now, you gotta understand, he wasn't a climate scientist or anything like that. He was an expert in ancient Sanskrit. So his tools weren't fancy lab equipment. They were the Vedas, these ancient texts, and some pretty complex astronomical math based on what those texts described.
So in his book, Tilak puts it all out there. He publishes his calculation, a single, really specific date. He believed that a huge astronomical event described in those texts had to have happened right around 7200 BCE. Now, his theory, it was controversial, and honestly, most people just dismissed it. He died back in 1920 with absolutely no way to prove it. It was just a number on a page, a theory that kind of got lost to time.
Okay, so now, let's hit the fast-forward button. We're jumping ahead 119 years. Forget the dusty old books. We are now in the world of modern physics and climate science, where teams of researchers are about to find a physical, tangible clue of an event from Earth's super distant past.
But how? I mean, how can you possibly see something that happened thousands of years ago? Well, the answer is pretty amazing. It lies in solar storms. When the sun has a massive eruption, a solar flare, it shoots these high-energy particles at us. As they slam into our atmosphere, they basically trigger these tiny nuclear reactions, creating a shower of really rare isotopes. And here's the cool part. These isotopes rain down and get trapped, year by year, in layers of ice and in the growth rings of trees. It's like a permanent fingerprint left behind by a cosmic event.
So scientists are kind of like cosmic detectives. They're hunting for very specific fingerprints. They're looking for spikes of carbon-14 in tree rings, and things like beryllium-10 and chlorine-36 in ice cores. Each one of these tells a piece of the story. And if they find a huge spike in the same year in both trees and ice from opposite ends of the planet, then they know without a doubt a massive global solar event happened.
But before I tell you what they found, we need some perspective. To really get the scale of this thing, we need a baseline. Like, how do you even measure a massive solar storm? Well, our baseline, our scientific yardstick for absolute chaos, is the Carrington event of 1859. This is the heavyweight champion, the most powerful solar storm in all of recorded history. And this thing was no joke. I mean, people saw auroras as far south as the Caribbean. The brand new telegraph systems literally burst into flames. The atmosphere was so charged up that operators could unplug their batteries and still send messages. People could read newspapers at midnight just from the light of the aurora. That's our benchmark for a crazy once-in-a-century storm. Just keep that in your head. Okay, now let's jump to January 2022. A team of scientists publishes a paper in a huge journal, Nature Communications. And they are not reading ancient texts, that's for sure. They are drilling deep into the ice sheets in Greenland and Antarctica and analyzing isotopes of beryllium and chlorine.
And deep down in those layers of ice, they found this. An absolutely massive, can't-miss-it spike in both isotopes. This wasn't some local blip. Because it showed up in ice from both the North and South poles, they knew they'd found the ghost of a truly enormous, planet-wide event.
So just how big was it? Well, their calculations showed that the storm that created this spike was somewhere between 10 and 100 times more powerful
than the Carrington event. I mean, just let that sink in for a second. An event so big, it makes our historical benchmark look like a little firecracker. This was a solar storm on a scale that's almost impossible to imagine. And then, just 2 months later, the plot thickens. A completely different team publishes another paper in the same journal. And they used a totally different method. They were analyzing carbon-14 in ancient tree rings. And they got their samples from trees on 5 different continents.
This was like the perfect independent check on the data. You have different scientists using a different isotope found in a different material, and guess what? They found the exact same massive spike in the exact same year. The evidence was just overwhelming at this point.
So, the big reveal. By counting the layers in the ice and the rings in the trees, both of these independent teams landed on a super precise date for this monster storm, 7176 BCE. This isn't a theory anymore. This is now a peer-reviewed, established scientific fact. And now we get to the heart of it all. Let's put these two findings right next to each other. On one side, you've got the scholar from 1903 with his ancient texts who came up with the date 7200 BCE. And on the other, you've got the scientists from 2022 with their ice drills and atomic analysis who pinpointed the date 7176 BCE.
The difference between those two dates is just 24 years.
24 years. Think about that. Across a chasm of more than 9,000 years of history, a scholar with a book and scientists with atomic clocks, separated by over a century of technology, landed on essentially the exact same moment in deep, deep history. This just forces you to ask a question that, the scientists weren't really focused on. They were looking at the data. But what about the people? What would it have been like to be on the ground in 7176 BCE and actually see this happen?
A storm 10 to 100 times stronger than Carrington? It would have felt like the end of the world. The sky would have been filled with auroras from the North Pole all the way down to the equator. The night would never get truly dark. It would just glow with this strange, eerie light. Clouds would look like they were on fire from the inside. It would have been a terrifying, beautiful, world-changing thing to witness.
So here we are left with these two totally independent paths to the same point in time. Path 1, ancient texts and the predictable dance of the stars. Path 2, the unpredictable decay of atoms trapped in ice and wood. The people involved were separated by 119 years. There was no collaboration, no way one could have possibly influenced the other. It's just two separate roads.
And that brings us to the final, unavoidable question. Is this just a 1 in a billion coincidence, a complete fluke? Or is this a convergence? A moment where two profoundly different ways of knowing, one ancient and interpretive, one modern and empirical, point across 9,000 years of history to the very same incredible truth.
Let's just pause for a second to let that sink in. We're talking about an event that happened 9,000 years ago. I mean, that's way before the pyramids, before Stonehenge. This is even before writing was invented. And yet, The difference between that ancient calculation and the modern physical measurement is just 24 years. 24! Over a span of 9,000 years, these two dates are practically sitting right on top of each other. It's just incredible.
I mean, if you want to get technical, that's a percentage error of only 0.27%. So you have to ask yourself, is this just a mind-bending 1 in a billion coincidence? Or is there something way more profound going on here?
All right, let's just take the idea of a lucky guess and throw it right out the window. To do that, we're going to look at the cold, hard statistics, and then we're going to look at something even more compelling, the descriptions in the story itself.
First off, you have to realize that these massive solar storms, the kind that are powerful enough to leave a permanent mark in ice cores and tree rings, are incredibly rare. In the last 10,000 years, scientists have only found evidence for a handful of them. On average, they only happen about once every 2,000 years.
So Tillich's calculation gave him a 160-year window. If he was just throwing a dart at a 10,000-year timeline, the odds of him landing in the right window by chance would be a tiny 1.6%. But here's the absolute key. He wasn't guessing, he was calculating, using very specific astronomical data that was preserved right there in the texts.
But it's not just the date that's so stunning, it's the descriptions. They line up perfectly with what we know a massive solar storm would do. And we're talking about something maybe 10 times stronger than the famous Carrington event. The story says the sun became too bright and too hot. Well, what does science say? A storm like this would cause global atmospheric ionization, creating this weird, persistent glow and making things feel hotter from all the particle bombardment. The story says clouds fled and twilight fled. Again, a perfect description. The ionization would totally disrupt cloud formation and mess with normal sunrises and sunset.
And the matches just keep coming. The story mentions people moving to a cooler region, which makes sense because the effects of these storms are less intense at different latitudes. It notes the whole thing was temporary, just like a real solar storm that passes. It even says healers were born afterward, which points to a long period of recovery. But most critically, it gives us the hard data, astronomical markers like the winter solstice and the Ashwini star cluster. Those are the coordinates that allowed Tillich to calculate the date in the first place.
So when you put all of these pieces together, the date, the brightness, the heat, the weird sky, the geography, the timing, it becomes pretty obvious what you're looking at. This isn't some poetic metaphor, it's not symbolism, this is observation. So, this begs the question, right? How is that even possible? How do you keep data that accurate for 9,000 years without a single written word? Well, the answer is that our ancestors had a kind of technology that we've almost completely forgotten, a highly sophisticated system for preserving data orally.
It was basically built on what you could call redundant encoding. It's brilliant, really. The first layer is the story itself. It's emotional, it's memorable, it's easy to retell. The second layer is the astronomy, the hard data that lets future generations check the date. The third layer is geography, which provides practical context. And the fourth layer is the phenomenology, the description of what it actually felt like to be there. So if one layer gets a little fuzzy over time, the others keep the core information intact. It's like a data backup system.
And the method they used to transmit it was just as clever. They had 11 different ways to recite the same text, so they were constantly cross-checking for errors. Every single syllable had a specific musical tone, like a checksum for accuracy. They had professional memorizers who trained from the time they were 5 years old, and different independent schools would constantly check each other's work. They actually preferred this system to writing because they believed it was more accurate. And, well, it looks like they might have been right.
But still, I know what you might be thinking. 9,000 years? Is that really possible? Can human memory, passed down from person to person, actually work on that kind of timescale? Well, the answer is a clear, unequivocal yes, and we have some incredible proof.
Just look at the oral traditions of Aboriginal Australians. Their stories talk about the Budgebin volcano erupting. They describe it breathing fire and throwing rocks. Geologists went and dated those eruptions. The date they got? 37,000 years ago. The memory was kept accurately for 37,000 years.
And that's not the only example. There are many stories from different Aboriginal groups about a time when you could walk to islands that are now way out at sea. Science has confirmed that, yep, about 10,000 years ago, sea levels were much lower, and those places were connected to the mainland. So preserving a memory for 9,000 years? It's not just possible, it's a demonstrated human capability. Okay, so that raises a really good question. If this memory system was so good, why don't we have similar stories about those later solar storms, the ones in 774 and 993 CE?
The answer, unfortunately, is pretty tragic. The system itself came under attack.
See, that storm in 774 CE happened during a period of non-stop warfare in India. Not exactly the best time for carefully recording new knowledge. But the 993 CE storm had even worse timing. It hit just 5 years before the start of Mahmud of Ghazna's invasions, which led to the systematic destruction of the very temples, observatories, and libraries that served as the hardware for this knowledge system. The chain of transmission was, quite literally, shattered.
And we don't even have to guess about this. We have an eyewitness account from a Persian scholar named al-Biruni, who was there during the invasions. He wrote about how amazing the sciences of the Hindus were, but then he sadly notes that all that knowledge has now been dispersed and has disappeared because of the conquests. He watched the memory system get destroyed in real time.
So after all that, what's the big takeaway? If this match between an ancient myth and modern physics is real, it has some huge implications for how we think about science, about history, and even about our own ancestors. For science, it means that oral tradition can be a source of actual, verifiable data. For history, it could push the date of our oldest recorded historical event back by thousands of years. For culture, it proves that our ancestors weren't primitive at all. They were incredibly sophisticated observers who were using what you could call narrative technology. And maybe most importantly, it means we need to start treating indigenous knowledge with a whole new level of respect because it might just be an archive of real, observable history.
But let's just bring it down to the human level for a second. 9,000 years ago, some people stood looking up at a sky that must have been absolutely terrifying. And in that moment, they didn't just panic. They made a choice. They decided, this matters. Future generations have to know about this. And then they built a system to make sure that message would be delivered.
In the end, this entire discovery really boils down to one simple, incredibly powerful idea. All those stories, those myths, those oral traditions, they might be so much more than we ever gave them credit for. The message actually got through. The ancestors were telling the truth. We just forgot how to listen. And maybe, just maybe, we're finally starting to remember.